Hello and welcome to module number 1 in Introduction to Statistics and Analytics using R. And this PowerPoint is downloadable to your computer, so you will be able to watch the video, but also to have the PowerPoint slide in the background. And I want to start with some encouragement. This is a common formula to calculate averages. Averages is something that we often apply in descriptive statistics. This is a little bit more advanced formula. But my goal and my objective, and I will work really close to you, that I want you to do better than average. And my goal is that in the end, you will have the knowledge and the know-how to apply this knowledge not only to do calculation, but also to apply the R in order for you to do that. But we need to start with the basic, and the basic is the idea of statistics. How the statistics is often defined as a group of methods that help us to collect, analyze, present, provide interpretation to the data to help us to make better decisions. So it is not one group, but it is a different methodology that applied to it. Why do we apply statistics and analytics into the analysis? It usually the idea to be transparent. It is statistics and analytics is universal language that everyone knows and everyone have understanding of it, and it allowed us to assess what is the alternative course of action if the result are not coming as we expected it to come, and it helps us to satisfy curiosity that we might have when we find data that is not we are not able to analyze, or something that comes out of the analysis. In all major fields, usually they are talking about two types of statistics: descriptive versus inferential. I will talk more today about those two types, but as the course will progress, I'm going to talk also about predictive analytics, where analytics come into play. But let's start with the basic. Descriptive is about collecting and summarize and describing the data. Inferential statistic, in comparison, is about taking a sample out of the population and help us to make better decision. So descriptive, as most of you already took probably descriptive course in the university, it's about a survey, collecting or presenting the data in table or graph, and try to come up with a standard evaluation such as standard deviation in order for us to have some understanding of the nature of the data. Inferential statistic is about taking a sample out of the population in order for us to estimate the population mean, and also to test hypothesis. What is the idea of testing hypothesis, and how do we go about it? As I said, we are going in this class, we are going to look at those three types of statistics in order for us to understand how it comes about in data science and how it comes so well in open source R. So key to definitions that I want you to keep in the back of your mind, because most of the reading will talk about those terms. One of those terms is measuring, and statistics is all about showing the relationship between the data and what we observe. In that sense, we have a population versus a sample. Population is a collection of all items or things under consideration. A sample is proportion of the sample selected for analysis. So in other words, a sample versus the population. And nowadays, in a year before the election, they're going to conduct a lot of samples to see who is going to be the next president, and they're going to report to us the different techniques that they use in order for them to gather the sample and in order for them to predict about the population. So every 10 years in US, we are gathering information about the entire population. It was a very big case lately on the news, and it is the idea of a sensor. So in the population, we take a sensor, we measure every single person that has a under his name that has a residence, and we go out and send him a survey in order for him to identify. A sample, on the other hand, is referring to the process of selecting from the population that represent the population. So why do we do a sample? It less time, allowed us to test different variables and to test different ideas about that, and allowed us to see if there is an effect. Usually when we are talking about sample, we are talking about two types. I'm not going to talk about non-probability sample. I'm going to focus my attention on probability sample, because non-probability is the idea that we randomly select something that out of the blue, and we will call it non-probability. Probability has more chance with regard to the population. And so if we look at the methodology, this is where each methodology is breakdown. Non-probability is a chunk or convenient or judgment, and probability is much more oriented towards verifying that the sample that we are taking actually represent the entire population, which is a key component. I'm going to break down each component of this probability sample, and each of them will have different components. A simple random sample is every individual or item from the frame has an equal chance of being selected. The issue is that the selection may be with replacement or without a replacement, and usually the selection of the individual come from a table of random numbers or from computer generate random numbers that we will learn to use in R in order for us to do that. Systematic sample, again, is a little bit more collaborate or a little bit more complex. We divide individual into groups, and we have the random selected one in the individual from the first group and select every key individual afterwards. So we have a structure how we do that, and that's why it's called systematic sample. We have another methodology, stratified sample, which divide the population into two or more subgroups, and according to that we have also a structure that divide that, and it allowed us to select from each subgroup, select the same number of people, and by that will build up for a sample itself. Cluster is again the idea of dividing the population into several clusters, and then using simple random sample to select the individuals from that cluster. There is advantages and disadvantages. Simple random sample and systematic sample are usually very easy to use. They may not be a good representation of the population under the study, but they are very simple to use. Stratified sample ensure the representation of individual across the entire population, so it's much stronger in that sense. And cluster sample is the most cost efficient with regard to time and money. So many companies using cluster sample in order for it to examine the population or example the sample, and it is less efficient, need a larger sample to acquire the same level of precision. So again, good and bad in each methodology that I present. But there is another issue that I want you to remember, is that data source. There is always the idea that we are collecting data, and the issue of collecting the data can be divided into two. The first one is that we go out of our way to observe or survey or go to a lab to do the experiment. A secondary data collection is going for a library or data collection and taking that collection and trying to analyze. Those are the two types of sources, and as a result, when we are trying to classify the data, we are often define the data into two types: categorical data versus numerical data. Categorical data is usually example of humans: are you married or not? Or political party: are you Democrat or Republican? Or the color of your eyes. Numerical, in the other hand, is also divided into two: discrete versus continuous. Discrete is something that is stable. Example, the number of children. Continuous is the weight. If I will start jogging and start doing exercise, maybe I will lose weight, and so please come visit me in 2 weeks. Maybe I will lose some weight. This is a continuous. It's always changing, and as a result, we need to take into account the changes that happen to the data. As a result, the level of measurements and the measurement scale is applied to type of data. The lowest level is numerical data, which is the weakness, and usually it is categorical, but there is no ordering or directions to what is worth a higher mark or lower mark. So it has no direction and there is no scale. Ordinal is a little bit higher and has some ranking or scaling, but there is no true zero. The next level is the interval data, is the difference between the measurement, but again, we do not have the true zero that actually a scale that actually help us. The true value of data is ratio data that has true zero, and this is considered to be the highest level. Why do we need that? Example, when we analyze speeches, a speech of politician or speech of the professor, we usually encounter a lot of words that has nominal data that has no categories. We cannot scale them in compared to formulas that has a true value or true zero value. This is where we come into a really precise definition. So those are the elements that I want you to pay attention when we are going to see that, and you're going to see that in your R code that we're going to learn how to apply. Another terms that we're going to see throughout different textbooks that we're going to cover is the element or the number. Element or the number of a sample or population is a specific subject or object. Example, a person, a firm or a country, or political identification. Variable is under the study that assume different value for different elements, such example, male versus female, age, income, education level, and so on. And data set is a collection of observation from one or more variables. Terms often used also is a variable that has discrete versus continuous, and the idea here is, again, example of discrete variable. Suppose you flip a coin 3 times, and so discrete, we have a value to it. Continuous, suppose the fire department require that every firefighters weight between 150 to 250 pounds, and what happened if is it between or some gain some weight during that time. So those are the differences that I want you to start paying attention to. And we also need to come close attention to cross-section versus time series data. Cross-section data is defined as data collected on different elements at the same point in time or for the same period of time. This is cross-section. Time series is defined as data collected on the same element for the same variable at different points in time or for different periods of time. So this is the format that I want you to start collecting. When I took the course 20 years ago, I used to have a notebook, small notebook, to take the definition that helped me to have my own vocabulary in place. And so I highly recommend that you do that, because one of the terminology that we're going to learn in this class is the open source R. So I hope you are ready, and I like this character that is taking from Cartoon's textbook on statistics, and we are going to apply that into data science. So what is R, and what is the professor talking about all the time? So the idea in the industry, in the software industry, we have two types of software. One is that you have to purchase the software, is the idea that every code in the software is been produced by one group or one company, and they identify with that, such as Microsoft Office. In comparison, the open source is a movement in modern computer community, and everything is free, but there is an issue of but it requires the user to be more active in the idea of an analysis and the idea of computing in order for you to produce the result you want. Example of open source, example Mozilla browser, example PHP web programming. Those are part of the open source platform that everyone can contribute, and every contribution is accepted and be tested before it adopted to the application, and that's part of the openness. We are open the application for everyone to see. And what is so important in R? R is a statistical software, and it started back in the early days, even before Excel, Microsoft Excel, that was created by Bill Gates. R is basically the idea that they took a code that was developed in Bell Lab, and two New Zealand professors converted into R that opened the gate to everyone to contribute. They call it R because the two first names started with R. And so the idea of R is that it allowed us to implement or to develop and create our own packages that we can share with others, and we will see that throughout the semester. And we are able to apply or use any packages we want and download to our desktop and run it in R in order for us to do the calculation. So the issue that you have to remember is that our package usually enhance the work of our in statistics. Example, the visualization in R, something that I highly recommend to see. And the idea of R comes in different packages, is part of the community. So R language is the idea of help us in programming language to apply that and to develop it, and ability to see what it is in order for us to understand. So R package throughout the years was defined as articles as articles that we often read in scientific community, but in compared to articles, R packages are standard. Example, we will see as standard we do not need to run descriptive statistic package, but if we want to do, for example, predictive analytics or predictive text analytics, we need to download a package that are suitable to analyze the data. There are more and more packages every day, and it is fun to see this development and to grow your understanding on statistics using the R. So what are we going to do with this R? We're going to learn statistic analytics through the eyes of R. We are going to download, you're going to download two applications, the R Console and the R Studio. Both we use both sometimes, but ours is not reliable. But again, the R Studio is the most stronger application that you will encounter, and I hope you will like it. I hope you download it. I show you the console. This is the first version of R, and the R Studio looks like that. This is the interface that you're going to use, and we are going to learn how to apply the editor, the R console, the variables that we are going to apply, and how we are going to use different help and packages, and how to plot or visualize the data in order for us to do that. I like to use cartoons in my spare time. I like to read them. I like to laugh about that. So in this case, are you ready for that? I hope you are, and I hope you will be ready for the next module. Until next time, enjoy